Hey guys, today we're going to do 4-8 complex numbers part 1. So we will be able to identify, graph, and perform operations with complex numbers. An imaginary unit I is the complex number whose square is -1, which means I squared is equal to -1 and I is equal to the square root of -1. When we are taking the square root of a negative number, we can now use the value of the imaginary unit I. So we are going to separate, see how we have the square root of -a. We're going to separate that into the square root of -1 times the square root of a, because we know that the square root of -1 is I. So we now found the square root of -a to be I times the square root of a. So if we are finding the square root of -5, we are going to separate the square root of -5 into the square root of -1 times the square root of 5. Since we know that the square root of -1 is I, our final answer would be I times the square root of 5. So let's simplify the square root of -18 by using our imaginary unit I. We are going to rewrite the square root of 18 by -1 times 18 I know is 9 times 2. I picked 9 because I know 9 is a perfect square. I know the square root of -1. I know the square root of 9. And multiplied by the square root of 2. So we can simplify these as 3I times the square root of 2. So an imaginary number is the number of the form a plus bi, where a and b are real numbers and b does not equal 0. The imaginary numbers and real numbers together make up the set of complex numbers. So you can write a complex number in the form a plus bi, where a and b are real numbers. And if b is equal to 0, the number a plus bi is a real number because that imaginary part is just going away because 0 times anything would cancel it out. If a is equal to 0 and b does not equal to 0, then we would have a plus bi is a pure imaginary number, meaning there would be no real part because we would only be left with the imaginary part. In the complex number plane, the point AB represents the complex number a plus bi. To graph a complex number, we locate the real part on the horizontal axis and the imaginary part on the vertical axis. So our y-axis is going to be our imaginary axis, and our x-axis is going to be our real axis. The absolute value of the complex number is the distance from the origin in the complex plane. So the way we do that is by using the formula, the square root of a squared plus b squared. So in our example, we had 3 minus minus 2i. So we have a and we have b. You're going to find the distance. We would do the square root of 3 squared minus 2 plus -2 squared. So we have the square root of 9 plus 4. So the distance, or the absolute value of this complex number, would be the square root of 13. So let's try and graph this complex number. we know that our real part goes on the x-axis, so our real part is -5, so I'm going 2, 3, 4, 5 on my real axis, and then my imaginary part goes on my y, so I'm going up 3, so here would be the graph of my complex number. If I wanted to find the absolute value of this, I would then do the square root of -5 squared plus 3 squared, getting 25 plus 9. So the square root would be the square root of 34. To add or subtract complex numbers, we are going to be combining the like parts of our complex numbers. So we're going to be combining our real parts and we are going to be combining our imaginary parts separately. So here we have 4 minus 3i plus -4 plus 3i. So we're going to look at our real parts first. 4 plus -4 is 0. And then we will look at our imaginary parts. -3i plus 3i is going to be 0i, which is equal 0 plus 0 is 0. We then also have subtraction. When we have subtraction, make sure you distribute the negative to both of the terms in the second set of parentheses. So we have 5 minus 3i plus 2 minus 4i. And we're once again going to combine our like parts. So 5 plus 2 is 7. -3i minus 4i is -7i. When we're multiplying complex numbers, we would be multiplying just like we would be multiplying binomials. So here we're going to take 3i and multiply it to each term in the second set of parentheses. So 3i times -5 is -15i. 3i times 2i is plus 6i squared. But what we do need to remember is that I squared, if we look back to our first slide, is equal to -1. So whenever you have an I squared, we're going to replace that with -1. So we have -15i plus 6 times -1, which is -6 plus -15i. And I'm going to go ahead and write it in my complex number form, so it was -6 minus 15i, because the real part comes before the imaginary part. Same thing for b. 4 times -4 times -1 is -4. 4 times -2i is -8i. 3i times -1 is -3i, and 3i times -2i is -6i squared. We're going to combine our like imaginary parts and replace I squared with -1. So this is going to turn into a positive 6. And then I can combine -4 and positive 6 to get 2 minus -8i minus 3i is -11i. Complex conjugates are a plus bi and a minus bi. Notice how the sign of the second term of the imaginary part are opposite. So we can use complex when we are, sorry guys, you know it's not my day. When we are multiplying complex conjugates, our product is going to be a real number. So here we have negative 6i plus I times negative 6 minus I. I'm going to multiply these and get 36 plus 6i minus 6i minus I squared. So our imaginary parts cancel because 6i minus 6i is 0. Our I squared turns into plus 1. So we have 36 plus 1, which is 37. So when multiplying complex conjugates, our product is a real number. So we can use this while we're dividing complex numbers. So we have 9 plus 12i over 3i. When we're dividing by a complex number, we want to multiply by its complex conjugate. So in A, we are going to multiply by 3i in both our numerator and denominator. In our numerator, I'm going to be left with 27i plus 36i squared. And in my denominator, I'm going to have 9i squared. When I have I squared, I'm going to change that to a negative 1. So I will be left with negative 36 plus 27i over negative 9. And we can go ahead and divide negative 9 to both of those terms. So we get 4 plus, I'm lying to you, minus 3i. In B, we're not going to multiply by just 4i, but we're going to multiply by 1 plus 4i, because that is the conjugate to both the numerator and denominator. FOIL the numerator, 2 plus 8i plus 3i plus 12i squared over. Since this is a conjugate, we know that our middle term is going to cancel, so we have 1 minus 16i squared. Replace I squared with negative 1s. Combine like terms. This is going to be negative 12, so we have negative 12 plus 2, which is negative 10, plus 11i over 1 plus 16, which is 17. You can divide both terms again, so we have negative 10 17ths plus 11 17ths I. You guys try these now and see you tomorrow. I don't even know.